1 minute. Just a minute. Is it visible now, sir?
Yes, sir, it is visible. Yes, sir. Yes, it is visible.
Okay, fine. Not a problem. Okay. So thank you very much, and we'll just take it forward. Before we get into the blockchain, I don't know how much was covered in the first two sessions. Let me actually try to cover up. Initially, I thought of how I have structured this entire session is that wanted to just give a brief about this blockchain for a few minutes, not because my the topic given to here is the blockchain structure and operations, like decentralization, distributed ledgers, and consensus. But anyway, I thought suddenly starting from there, I thought initially to take it up, like more related to the use of blockchain and how it is, why a lot of confusions are prevailing over blockchain, implementation of blockchain in the government, in certain industries and sectors and all those things, where it is leading to chaos basically. So that's why I thought of covering this one. So initially, a few slides I want to talk about these things, and then we'll get into the actual technical issues and all. Anytime people are, we can actually have some sort of like last 15-20 minutes for any doubts and discussions, or in fact, if anybody wants to raise questions, so you can actually raise your questions in between also. I'm fine with it completely on that one. Okay, so I'm just getting into the concept. For example, I wanted to, I want to just give a prelude. For example, like let us say a person A, he wants to buy like 10 kg of rice. So B has a paddy field and he produces say like 10 ton of rice every year on that one. So normally A has to buy the rice from the department store. Normally when we go and all, he buys, and when he buys, he pays a GST on the items bought, including the rice and all those things. So the government gets the revenue. So transactions are also known to the government on this one. Suppose A directly buys rice from B. So B does, for how it can happen, for example, B does not report the entire produce to the government. Instead of 10 tons, he reports only as 5 tons and sell the remaining 5 tons to various people like A, that way and all. So the transaction of A, the A to B, that 10 kg of rice will go will not get noticed by the government, and government also will lose the GST revenue pertaining to sale of the 5 ton of rice. So this is where basically that how it happens is basically the transaction doesn't come under the network which is currently prevailing within the government completely. Whatever may be the system we are prevailing, it is not actually going on that one. But however, we use the money. What we use the money what we use is printed by RBI. So that way, one way or the money is in the circulation and all. So this is one scenario where there is a transaction loss on that one. So now we see, what if B accepts a type of token getting circulated among a set of villages? So each token is valued at say 100 rupees on that one. So it becomes a counter currency which is against the law as well. Similarly, what will happen if the same token can be used to accepted by many players like home appliance sellers? So government will stand to lose a huge loss due to this parallel economy. This is where actually there are two networks basically on this one. Now coming to this parlance, the blockchain, it's there are two aspects of blockchain. Blockchain, one is related to Bitcoin. Bitcoin is a currency used in the blockchain, which need not be a Bitcoin also. There are other ways where we can handle without Bitcoin also in the blockchain. That we'll cover it later. But they said like a token. So there are platforms like Ethereum and all open source platforms where those platforms, for example, now you may find that just to give a comparison with the layman types and all. Now there are a lot of websites or a lot of companies, startups offering you, saying that you can create your own website. You can create your own website without having any coding idea. You need not have any coding experience. All they say is that no, you have to pay the money and then you can set up your own website. They drag and drop, you can set up your own website. They will guide you step by step like that. So there are a lot of startups coming, in the blockchain area. Also, there are companies like Ethereum and all, which is coming, which helps you to set up some sort of a blockchain-based transactions on that one, where you can actually know we can get their help. These are open source platforms. Some to some extent it is free. Somewhere you can get some idea. So you can actually set up all those things completely, and then you can actually use the blockchain for whatever you are using. For example, one of my friend was trying to use this blockchain concept in the matrimonial aspects basically. So he was talking to me sometime back, couple of months back. He was saying that, sir, I am planning to come with the idea of blockchain using the matrimonial sites, because it is more secured on that one. So it is not open to the public. So that way and all, he was trying on that one. So people can try different things. Where the problem comes over here is basically, for example, you are setting up a website. For example, you are you are a seller of some items. Say you are a producer of manufacturer of shoes, and you are trying to set up a website on that one, and you are trying to sell the shoes using the online, which the website what you have created. The interaction of the money comes through the network. The network is monitored by RBI, NPCI, all the people and all. So definitely it is not going, and the money you are using is also either it is a dollars or it is maybe Indian currencies, anything it is there, you are able to use it completely on that one. So there is no problem at all, basically, because everything is invoiced and taxed and all those things. What if, like previously what I was telling you, like it is like a token which is not recognized, only recognized within the network, like how the rice seller trying to sell the 5 tons of rice using the tokens. So if he tries to just accept some sort of like bitcoins on that one, and he accepts the bitcoins, so there is a likelihood of government not knowing the entire transactions completely. And so this way the government is somewhat bothered about the loss. The controls are going out. Similarly, for example, if I am a big money lender, right now how I am lending, either I can actually have the money, take the risk of lending the money by myself, or I can deposit the money in the bank, and the bank is taking that money and lending it to the people right now. So what if I am trying to take entire stuff and try to lend using the blockchain network, where the transactions need not be, and I actually convert all my money into bitcoins, because you can purchase bitcoins on that one. So I take the bitcoins, I actually I purchase, say, 1 lakh rupees I have. For 1 lakh worth of money, I take the bitcoins and keep it with me, and whoever asks the money, I just give it to them and earn interest out of it. I am also encouraging them to pay them back through bitcoins on that one. So entire thing goes without the knowledge of the government completely. So this is where it was going on. In fact, I was also working with a couple of consultants who were also consulting with the Reserve Bank of India. So Reserve Bank of India, sometime back, I don't know what is the current status of the paper and all, the consultative paper. They were trying to do they were trying to coin the name of Bitcoin as Lakshmi, like that. So for example, Ethereum, the platform what we use for blockchain creation, the name of the Bitcoin is called Ether on that one. So in fact, Reserve Bank of India was also trying to say that name the Bitcoin as Lakshmi on that one. So how they plan to bring that regulations is basically, right now also you can purchase Bitcoins through authorized one, but you have to produce the KYCs and all those things so that it comes under the government control. So that is how basically it is the Bitcoins are getting planned to be managed and monitored right now. But the point is that many get confused about blockchain and Bitcoin one and the same. So it's not only about Bitcoin. Blockchain is not only about the Bitcoin. It is more about bringing the transactions completely decentralized. That's where we are getting into this one. How to do this one? For example, how the blockchain architecture is getting decentralized is basically, you see on the left side, you see that client server technology which is being used right now. And especially after, say, 2010, the advent of API, application provider interfaces, what we call APIs, brought a lot of changes in the way what we are actually transacting in the networks, computer networks. How? In the sense, basically, like earlier, when we are used to have the data, access to the data, the entire database or the identified target database should be opened up for the people who are accessing it. The application provider interfaces enable the technological world. For example, if I am in a bank, I am a customer of a bank, and you are somewhat a farmer or somebody or whoever wants my data related to that one, and you have a tie-up with the bank to retrieve any customer data related to that one. So you can request to retrieve only my record. So bank need not give access to the entire database. Only that record you want, okay, related to JP, that record you can actually always get it. So they provide access to that one specific record on that one, where we can actually post the request and get the call on that one. That's based on API only. Right now there is a humongous growth of systems across the world. There is a good interface where you are getting a seamless interface. For example, when you are paying in Amazon also, typically what happens is that you are able to get a seamless experience. You select a product and then you pay for that over a credit card. It immediately connects to the banking network, and from banking network it actually connects to the telecom network, which sends OTP. From OTP you are able to feed in. So all these are getting seamlessly done through the API protocols completely. So that way it was good. So people may wonder, if everything can be achieved through that one, why there is a need for a blockchain? Because because the systems are very good and all those things and all. So there is the seamless which all of us are now experiencing with respect to even from Paytm, Google Pay, all those things. We are getting a seamless experience on that one. So why there is a need for that one? There comes a blockchain architecture where, if you look at the left-hand side, the point what we see here is there is one server. The server stands as a repository of all the transactions and all those things, and all the other systems are only client to the server. So entire database is stored. Maybe 2 days, 3 days back also, you might have seen that Reserve Bank of India have slammed HDFC Bank, stating that their credit card transactions are not going properly on that one, all these things and all. So and they have issued a notification to the HDFC not to issue any credit cards till this issue is getting solved, because some of the customers faced problem with respect to even drawing cash from ATM and all. So everything depends on network and on server on that one. Whereas in blockchain, when you come, it is peer-to-peer network where all the network is connected, where there is no server in between on this one. That's where that makes a difference. And blockchain cannot entirely replace the entire systems. Definitely not. It cannot do that one, mainly because of the level of transactions and all what we have. It cannot entirely replace on that one. But certain places, it plays a very important role. And with proper regulations, everything in place, it can actually give a lot of transparency to the people who are dealing with the blockchain architecture. So now, next one, what we need to find out is a blockchain about in nutshell. So blockchain, it's digital concept to store data, number one. So this data comes in blocks. So the data is not stored in our traditional conventional forms like what we see in SQL or Excel sheets or something like that. It is stored in the form of blocks, and these blocks are chained together, makes a blockchain. So this is where we stand right now. So let us take an example of how to create a block. So creating a block here. So for example, and one more thing I want to add is that basically the blocks will not be very big sizes. The size of the blocks will be 1 MB. It's very, very small blocks. That's how it makes and all. You can't imagine what we call as a big data types and all. No, it is all small blocks on that one. For example, what I thought of giving you some examples is that, for example, there is one block, it is being created. So there is one Damien and say George, Bernard, Gerald. 4 people are there. There are 2 transactions where Damien has given 100. Maybe it's given us Bitcoin, we can consider as rupees. So 100 rupees to George. And in the second transaction, there is another Bernard who is giving 200 rupees or Bitcoins to the Gerald on that one. So where, let us for a time being, let us see, this is the transaction. This transaction is stored. This transaction is stored in a record, basically. This record, we actually stamp it with a string data. For example, like here we call it as x32. Just for the time being, forget about everything. We are just keeping it as a x32. This is the signature. What we call it a signature. We have just kept it over here. Now, this x32. So there is another transaction. What is happening is that there is T3, T4. There is another transaction happening between Damien and George and Bernard and Gerald. So what happens here is that basically, like this is second block where it is the transaction is received on that one, and where we have is that basically the one block is transacting with the other block. So where the signature x32, it is connected to the second block, and the second block produces another code, unique code. So what we call it as 9BZ, like that. So where is this 9BZ will be used is basically this x32, the code created by block 1 is being used to connect with the block 2. So now the 9BZ will be used to connect with another block, block 3 actually. So this is the unique code has been created over here. So now we are seeing here like the next one. So similarly another transaction happens in the block 3 on this one. So where we find is that 9BZ is linked to the block 3, and block 3 generates another string of data called 74T, which can be used to connect with the another data. So if you look at base, each transaction has been put into a block, which is nothing but a data actually, which is encrypted, which is being encrypted. And the encrypted data, what we have given a code, a signature code over it, and the signature code is used to connect with the next block. So each one is connected over a block. That's why it forms a chain. We call it as a blockchain right now on this one. So altering a chain, basically, like suppose one guy wants to convert, say that the previous one, what we see is that the transactions in block 1, 500, 500, 200, 200 over there. Now you want to just convert the chain from say 500 to 100 on that one. When you enter any changes over it, you find here this x32 in the left hand side, first one. Now when you enter any changes over here, this will get changed to say W10. This W10 will not match with the second block, mainly because that becomes an orphan block actually. So it won't be able to connect with the next blocks. So the next blocks will not be able to recognize this one. How it happens over here, that's what we need to see that one. So entire block, so unless otherwise it matches with this one, it won't be able to connect. Unless otherwise the other blocks also correcting it one with the block 1 on this one. How to convert this one? We are just taking it out. So here, when we see here, all the blocks should have the similar, all the signature changes. So when somebody is changing this one, the other signature should also get changed to the next blocks, so that all are actually connected over here. So here, unique signatures basically becomes very important, and one place we change means all the places we have to change till the end of the chain. So it won't accept if you are just stopping with only one place. So to the end of the chain should be changed and all. So which is not possible over here. I'll tell you later on how to look into this one and all. I'll cover that portion a little later. But now coming over here, we just explained this with say W10, say PP4 and 74T. This is like one, but actually in the actual blockchain, you don't get like a W10 or something. If this is very simple, this entire blockchain world would have easily cracked all the signatures easily. But what they made is that they made some sort of like a hexadecimal. What we see down below here is, for example, there are hashtag generators. I wanted to just give there is a site for password generators and a hash 256 bit hashtag generator on that one. There are a lot of similar generators like this, where you just type something like, no, for example, I typed welcome to the blockchain workshop. So down below, you find that no hashtag is getting generated, where you find a list of numbers. So this is the code generated on this one. The problem here, for example, now how it changes, like no, you won't find any differences. Basically, know how many words and all, always this 16 digits hexadecimal will be created. You won't find any differences over here. I will just go back two slides back, so that you'll be able to see. For example, like this guy, like no altering a chain. When a guy changes, initially it was x32. So the guy changes something, it changes into W10 basically. Once he changes to W10, it won't match on that one. So whatever he changes on this one, even a full stop he changes, it will be that one. I want to just show you here. For example, no, this is how like no input changes and all. For example, you input a fox. So you put, instead of like here in this slide, I put welcome to blockchain workshop. Instead of that, you put say fox on that one. So it gives this sort of like no the digest basically, which is like generates some sort of a code over here. And similarly, no, now you change into say that no red fox jumps over the blue dog. So again, you change it out. You may not make the same difference because the entire digits remain the same. Number of digits remain the same over here. You won't make any changes. So you can't make out whether this has only one word or two word or three word on this one. So whatever a small changes you make, the third one you make, instead of over, you are just making OU. Instead of V, you are making OU. So entire stuff changes completely. So it is no parallel thing is over here. Similarly, when you make small change, so a small change will make a change. You can't make out what this is all about. So the entire cryptic, the digits remains the same. There's an hexadecimal which remains the same over here. So whenever I'll just again go back here, I want to just connect again back and show it to you, saying that when a guy changes over here, it will not be W10. It will be some other string. It is just getting converted into the completely on that one. And it should be matching the other things. How to match it out, I'll explain you a little later over it. So how miners are working over that and all, I'll explain to that. But here, what happens here is that once you make any changes, irrespective of whether you make a small change, a small full stop or something like that, the entire hashtag changes. Hash function changes completely, which has no relevance to the previous one completely. If you look at the first two on the pink colored boxes, there is no relevance over it. So it automatically changes. This is equivalent to your like no OTP, what we actually know get experienced in the one. We don't get the like no the OTPs in a similar fashion over here. So that way and all, like no we can't actually say that which is correct and which is like no, we can't predict the OTPs typically. So same way, we will not be able to do this one like that. So that's how we actually have it. So the hash function as signature is that though it is very easy to calculate the hash for any given data, you can easily create a hashtag, but to decode it, to just decode it, to find out like no what it actually means. For example, here like no the fox is there. The second one is red fox jumps over the blue dog. That is one thing changed and all. Now the second one is having 0086, it is starting and all. Now it will be very difficult to find out what is returned from 0086 to the red fox. It is very extremely difficult to decode on this one. And it is extremely unlikely that two slightly different messages will have the same hash. That is again, it's very proven, right? If you look at the third one and fourth one, there is only like no a small change is there. There is no jumps over the blue dog, basically OUER. Next one is OEVR. But what you find on the right hand side is completely different. So it is very extremely different over here to like no to decode it, that one. Similar like no like QR codes and all, what you find in Paytm, Google Pay and all. A lot of QR codes are there, but not like no two QR codes are similar on that one. It's very extremely difficult to decode on this one and all. So now the hash, for example, like few slides back, we were just showing that, like here, we were showing this like a W10 and all. Actually, it is not W10. I was telling you, it will be in the form of a hash codes. How hash codes are getting created also, I showed you here, how it is being done and all, and how it actually changes also, I showed you here on that one. We can't make out and all. And now this is how, like the once you enter a transaction over here in one block, the block creates a hash code. The hash code of this one block getting added to the other block. How it is getting added, I'll cover it little later on that one. So what if the one person changes all the signatures continuously on all the block, right? For example, no, like there are 4 persons over there, and each person is doing some transactions, and the transaction is in one block, and that block is getting generated one signature, hashtag is there, and next one is getting added to the next block as the connector. We can, in layman format, we can connect it as a term it as a connector. So it is a connector. It is connecting to the another block. Now, what if I can actually take hold of everything, and there are say 10 blocks over here, which is involving say 50 lakh worth of transactions between this one. What if I can catch hold of all the hash and connect with all the hashes and take the entire network? Is it possible or not? In client server architecture, it is possible through hacking on that one. But in the blockchain, it is extremely difficult, mainly because the first thing is that decoding this one without getting a public key or a private key. I'll cover the public key, private key also little later. Getting a key access to it, basically extremely difficult to decode all this one. So for example, I have transacted with say Aragapa University over it and all. There will be one hash code generated over here where I have done that one. So even if you are able to decode my transaction, if the transaction may look like one of these numbers completely, you are able to do this one. By that time, you try to make a change in the Aragapa University's hash code and all, somebody would have transacted with Aragapa University, that would have again changed. So it will be extremely difficult for you to hack all the systems, because even a small changes, you will be able to, it will change another immediately the codes over it. So that is where we are actually it changes the entire stuff on that one. That is why we call it this mining process. So why it is also difficult, I wanted to tell you why it is difficult to decode also. Here, the answer is only hashes or signatures that meet certain requirements are accepted on the blockchain. This is called mining process. A block will be only accepted on the blockchain if the digital signature starts with some values. For example, you can create a blockchain where you can actually say that initially 50 should be there for that one and all. Like that you can set it up. And for example, only blocks with signature starting with at least 10 consecutive zeros qualified to be added to the blockchain, something like that and all. So all those things, it becomes very difficult for us. So let us say how difficult, I wanted to just give some layman analogy, to convert on that one. Say, let us consider there are 3 people, A, B, C, 3 people are there, where we find that 3 people. So A was asked to think about a number, say within 1000 on that one. So A is thinking of a number, and B and C should give a guesswork to match A thought of what A thought of. So A thought about a number of say 454 is a number what he thought about. Now B and C can try many times, and when they match, it is called mining. It's just in a layman terms, I want to tell you. So they have to try within 1000. So people will ask, B will initially say 100 not matching, say 150 and all not matching and all. So it is basically it's called mining on that one, which even this in client server architecture also, where we find that the hackers use this one, ethical hacking or even other hackers, how they are able to intrude into your network is mainly because they try with a lot of passwords completely, list of passwords, whatever combinations and all those things and all, they try to attack. So that they give that one. So that is happening even in the other network. Where it makes very unique is basically the changes is in the hexadecimal right now, and once it should match, then matching is not going to be easy on that one. I'll cover that one also a little later on that one. So why it's basically what we call it as a nonce. So nonce is like a random or semi-random number that is generated for specific use, typically related to cryptographic communication or information technology. So nonce is more related to number used once, number one. So you can't use the same number, and typically you can try many times, but not the same numbers on that one. And so what put all together here, what we try to do here is basically like for example, we create several blocks. One block is having a transaction data, and there is a signature block over here, and there is a hashes to signature where it is signatures are getting created. You think about the signature means the signature generated, whatever it is there and all, you are creating on that one, where it is exactly connected to the next block through the same numbers, where no, like 00P3X22A, that is getting connected on that one. So similarly, again, another is getting created. So next one, block 7 is also created. And so random nonce here, it will be on numbers. Basically, it won't be like this one. Again, it is a number. So the next one should start with the zeros, all this one and all. So that is where we do that one. Here, there are two aspects which we have to be very clear about it. There are two aspects in this block creation on this one. One is related to mining a Bitcoin, which is completely a different ball game from a normal blockchain applications and transactions. Just keep these two as a separate world completely. Now, let us keep this slide as a base here. What we see is that assuming that this is a Bitcoin related thing, so now a guy wants to mine a Bitcoin. Basically, what he has to do is that he has to work on the computers to generate hexadecimal numbers, signatures completely, several combinations, what we call it as a nonce. We have to generate so many signatures on that one, so that it matches this one, what we call it as, like for example 00112 LL cake 4, something like that. It has to match till the time he has to work. So it is not like a mathematical equations. People call you have to solve so many mathematical. No, nothing like that. Basically, you have to solve so that it matches. How it can happen? It is extremely difficult right now because a lot of blocks are there, a lot of blockchains are there right now. So what they use is that sometimes they use like big computers, like spending on electricity in the form of computational power in order to insert as many random nonces as fast as possible, until they find a nonce that together with the rest of the block data leads to hash output that starts with at least 70, this way and all. So once I am having a computer where I am trying so many times so that it matches on that one, I'll get 1 Bitcoin out of it. So that way and all. So that is how we call it as a Bitcoin mining. We call it as a Bitcoin mining because it matches. So how fast or how quick we can match it out? There are people who are investing lakhs and lakhs of rupee, to actually put a lot of computational power to generate that one. And there are instances where some people with a normal network also were able to crack. That's a pure luck. It's not related to anything related to computation. It's pure luck. So sometimes they get, sometimes they don't get on this one. So the more the Bitcoins are mined, it gets added to the block that way and all. So as long as the people are able to use the computational power to match the block, you earn a Bitcoin for that one as a reward on this one. So that is how once Bitcoin is mined, that Bitcoin can be sold, for which you need not do all these things. All we require is a private key and public key that I will cover a little later. So Bitcoin mining is a separate work where we actually use a lot of computational powers to do this one. Once Bitcoin is mined, where the blocks are added to it, then later on it is very easy. Basically, you can buy Bitcoin. You can even certain entities allow you submit a KYC. You pay that money. They will give you a public key, private key, whatever according to the norms and all. You can buy the Bitcoin. So there, all this process will not be that much tough on this one. So coming to the point, say assuming that there are so many blocks and all, assuming I can actually hack around all the things which I was telling, like a corrupt miner has altered a block of transactions, now trying to calculate a new signatures for the subsequent blocks. In order to have the rest of the network accept this change, The problem for him is the rest of the network is also calculating new signatures for new blocks. Simultaneously, it is calculating. I wanted to just bring an analogy. For example, in an Excel sheet, for example, in Excel sheet, there is a function called random number generator. We have that. So you put, for example, A1 to A10. We are actually putting on random number generator, say 1 to 100. So it will generate some random numbers from 1 to 100. First 10, A1 to A10. So 10 numbers will be generated. So you might have observed that when you just copy it and you put another next column B, where you again use B1 to B10 for random number generation on that one. So it will give another number. Now you create a C column saying that A plus B, C is equal to A plus B. So it will add both the numbers and give it over there. What happens is that you make one change. You might have observed that you go to the A column and make one change in one column and all. Immediately the entire random will get changed completely on this one. Similarly, so when you just even copy and paste, so that's why we sometimes use the paste special value, basically paste special, where we actually paste only the values. Otherwise, what will happen when you copy and paste only, it automatically changes. Same way, you try to hack one block, try to decode the signatures and take it up and move to the other one. Immediately, the other blocks would have got changed completely. Again, you have to, so that the same patterns won't follow. And it is, if it is for one block, it is more blocks and all, you should have big computer network, very big computer network, such that you will be able to hack all the things at the same point of time. You are attacking all the blocks and changing all the things in one shot. That is not possible, mainly because this is a P2P network. So that is where the difference comes. What is P2P network? It is a peer-to-peer network where you don't know how many computers are getting used also right now. Maybe in one blockchain, there may be 1 million computers will be put into use, where each is part of the network, blockchain network. So assuming that a blockchain is having 1 million computers in this network, probably your network should be having, say, 3 million computers, which is impossible for a guy to actually hack all those things. But still, you might have heard that there are hackings happening over blockchain. How and all, I'll cover it a little later towards the end of this session on this one. So what we see here is that he needs to keep all the blocks linked, including the new ones, constantly being added. Unless the miner has more computational power, the rest of the network combined, he will never catch up with the rest of the network finding signatures. That is very clear. So that way and all, it is very safe. Whereas in a normal business environment, for example, to hack a bank network and all, it is only one server, right? It's one server. Maybe it may be several distributed servers and all. Maybe it is different places and all. It is very easy because once they may have a lot of computers in the office, the banks, but there will be 1 or 2 servers only. It is very easy to hack that one server. But here, since it is spread over in the P2P network, you can't keep on changing all those things in one shot. That is one thing. This is the P2P network, what we cleared, and the blockchain, how they point us and linked list. This is one of the terms I thought of covering some of the terminologies also, apart from the concept, mainly because people should get used to the terminologies. That is also very important. So what we thought is basically there are 2 things like blockchains and pointers and linked list. The pointers, what we call it, is the variables that keep information about the location of another variable. Specifically, this is pointing to the position of other variables and all. This is basically the pointers. It is like our address typically. So where it exactly it is there and all, because there will be so many blocks and all, it just points. And the linked list is a sequence of blocks where each block has specific data and links to the following block with the help of a pointer. So a lot of blocks are there. It should go in the proper block. So which block is next basically. So that is the pointers and all. How it will look. So this is a concept theory. How it will look and all. Basically, this is how it will look, the structure. Basically, the pointer, there will be head. So remember that there's a transaction. The transaction after that, there is a pointer. The pointer will lead to the record from head, which is the record 1. Then the next pointer will do to record 2 and all. So there will be a lot of records. So it will actually point out which record is the next block, actually, where it has to go and all. That is the use of this pointers over here. So again, like no, I'm not covering Merkle root because I saw some other sessions specifically handling the Merkle root. So I'm not getting deep into that one. So typically, the block one header, hash of previous block header, and then basically, like it is connected on this one and all. So that way and all, like it is the pointers and linked list helps you on that one. So another thing what we have to know about is nodes and master nodes in this entire blockchain network. Nodes and master nodes is basically it's related to there need not be master node, there can be a master node also. What is a node is basically is blockchain exists out of blocks of data. The nodes can be of any kind of device. Basically, like any computers. What we call each computers as a node, and it is connected constantly. It is connected on that one. So that way and all, it is every computer is called a node on the one. Then what is a master node? The master node is something where heavily equipped than normal nodes. So it is basically it leads to the validating the transaction, broadcasting transactions, sometimes like that. So and nodes can be online, offline. For example, you are part of a blockchain and you are one of the node. Your computer is one of the node. Not necessarily it should be online always. It can be offline. And whenever you actually connect back to the blockchain network, it updates all the transactions on that one using the keys that way and all. So that way and all. Whereas master node should be online always. It is like a server, basically, like in your client server architecture, server types and the master node that way and all. So overall, so far, like what we see here is that how the blockchain flow happens over here. The blockchain, let us see that for example, a transaction is requested. For example, I am part of a blockchain. I have joined the blockchain network, and I'm initiating a transaction to transfer some money to some other guy, or make some transactions. Basically, let me say that even as I'm part of, say, insurance, claim processing, okay, not involve money always. Let me take another example, saying that I am part of an insurance network where I have to approve a claim, basically a motor insurance claim. Like some accident happened, I have to approve that one. So transaction is requested. Like I am requesting a transaction. So transaction is created that so and so vehicle and all those things. It is this has to be solved on that one. So now this will get into, so this request should be approved by various authorities. Who are all those authorities? For example, like it should be approved by the insurance company. It should be approved by the surveyor who actually estimates the loss of your vehicle, how much it is lost and all. There is a garage who will give you an estimate of the vehicle, how much is the loss, how much will be the estimate. So there are many transactions happening over here, and assuming that all are part of the blockchain network, all are part of the blockchain network. So what happens here is that now you are actually entering that one, and a block is created. The block is sent to every node in the network that this block is created, and everybody will have access through a private key and public key, which will cover. So once you enter that one, you will be able to see the transactions, what is happening over here. There is no money involved here. Because for the time being, I want to keep the Bitcoin and money safely out of this one. So there is no hash. So the hashtags is in the form of a private key, which is being given to us. So now I'll enter that one. So I will be able to see the transactions. So a guy has come. So I am the garage guy. I am the insurance guy. I receive the claim request. I process that one and using my key, access the data, make the changes and see that yes, it's a valid claim. Some accident have happened. The guy has a valid insurance. The guy, I approve that one. For the next level. Next level is typically there's another block which actually goes to the garage guy and all. So garage guy gives the estimate, survey. Like this entire chain is completely covered, entire network on that one. The advantage over here is that everyone can see what is the transaction happened over here on this one. Now the question will come, the same thing is happening over your client server network also. For example, the same thing is happening, right? As I told you already, let us keep aside the Bitcoin mining for the time being. I'm just taking the insurance only, where the transactions only. There is no money involved here. Now the question will come, the same thing is happening over in a regular thing. Sir, I am able to see in my mobile phone where my file is pending, my claim file is pending, how much is this getting processed. All those things I am able to see this one right now. So why there is a need for a blockchain? Why I have to break my head of all these things? Now the question comes over here is that this API, like no APIs, cloud, and the client server are prone for attacks. So if I can go back, I can catch hold of the server and make any changes in the claim amount. Nobody will know about it except the admin guy of the server, because he can take a transaction list, audit trail of the system to find out, array, somebody has changed the claim amount. Suppose I submitted a claim of say 50,000 rupees. Later on, I want to do some changes and make a fraud saying that I want to make 1 lakh rupees and all. Now the problem, what happens here is that anybody can change without, say, I catch hold of the server guy who manages the server and say that boss, make the changes, remove all the transactions on that one. It's very easy. But in the blockchain, if I make a change in one block, what happens is that the hash initially created during the transaction, it gets changed. And it won't be connecting with the other blocks. Right? There the disconnect happens on that one. So unless otherwise it is connected. So I made a change, assuming that it is a client server architecture. I will be able to, I caught hold of the guy who manages the server. Initially I submitted as 50,000 rupees as a claim, now I want to convert it to 1 lakh. I can actually go ahead, request saying that no, make a change, I'll pay you 10,000, 20,000 and all, make the changes. Nobody will know about it. All other documents, paper documents are in sync with the changes, whatever I have made on this one. Very easy for them. Nobody, unless only that guy has an audit trail of the system, nobody can know about it and all. Now here, it is completely difficult because I made a 50,000 to 1 lakh. The next guy is say insurance guy or the garage guy. The garage guy will not be able to connect, mainly because hash has changed. To get a hash changed, syncing with the garage guy, it's again difficult for me because I have to catch hold of garage guy. I need to catch hold of the surveyor. All the people all together know all the hashtags, enter properly. Very difficult on this one. So that makes the changes very, very difficult, and it will be remaining in this system forever. So it won't be possible for me to make the changes entirely on this one. So that is what I'm doing. So coming to the point here. So the first one, second one, third one is blocks sent to every node in the network. The nodes validate the transactions. Node is nothing but the computers or your mobile phones or whatever it is there. Yours is the, because mobile phone in the sense, if you are registered as a node in the blockchain, it becomes a node actually. It sees that one node receives a reward. This is related to Bitcoin. For the time being, we say that no, it is related to approval of transactions completely. So once it is approved, then the block is getting added on this one. So then the transaction is complete over here. So this is the blockchain flow around it. So this is how actually the blockchain works entirely. So coming to this, basically, I want to reiterate, there are two things. One is related to Bitcoin, where mining is involved. The other one is related to transactions. So transactions and all, creating is very easy. Easy in the sense, basically, no systems. We need to find out, which is, we can actually create a system of blockchain for transaction related things, where there's no use of Bitcoin and all. We can actually use the blockchain on that one. When it comes to Bitcoin mining, then I have to go back where I am able to, I'm just show here, I want to reiterate this one, where I need to use my computer powers, like combining hashes and all, to find a computer power, so that what was a lost block left, the hash, I need to use some computation power to match that hashtag. So when I'm able to match the hash, then I will be able to mine a Bitcoin, mainly because that forms a block and get added to the things and all. So that is where we stand here. Now coming to the next one, it is basically getting one level deep into the distributed ledger. What we call the distributed ledger is nothing but a database that is consensually shared and synchronized across multiple sites, institutions, or geographies, which I was telling you earlier, accessible by multiple people. So it allows transactions to have public witness on this one. So the participant, and whenever I say all these things and all, you should keep in mind only one thing. You may get confused saying that even the current systems are having the APIs, whatever the client servers and all. For example, no, like even when we are sending a speed post, basically, no, like a speed post, it actually continuously you can monitor where my thing is there and all those things are available. Why there's a need for a blockchain? Basically, don't get confused over here. Yes, those things can be handled over that one, but the problem is that if it is very important data over there, where you should have more as I told you earlier, like servers, if it is getting hacked, you can change the data. But here in blockchain, even if you change data in one block, it won't get connected to the other blocks. So unless otherwise it's chained completely. How it is chained? The chain is connected through a very complex hexadecimal signatures completely. And once you touch something, it again changes. So you won't get the chain of transactions on the one. So that way you can still have the entire transactions, and it is very secure because one person cannot secure access of all the computers to change all the things simultaneously. That is where we stand. So what we see in distributed ledger is that the participant at each node of network can access the recordings shared across the network and can own an identical copy of it also, where you can have it in your own computers. Any changes or additions made to the ledgers are reflected and copied to all participants in a matter of seconds or minutes. So make the changes. If it is connected to the node, immediately it is reflected over in the, like it is happening even in the current client server architecture, similar to that one only. The distributed ledger stands in contrast to a centralized ledger, which is the type of ledger that most companies use. A centralized ledger is more prone to cyber attacks and fraud. As I told you already, it is what we are seeing. For example, when we book a speed post and I receive some sort of like a acknowledgement and all, basically it is, we are getting all the updates, but one thing is that it is coming from a single server. So anytime you just catch hold of that one, you can change anything, whatever you want. So where it is going problematic is basically there is not much of the governance over the existing system. That is one thing what is happening over here. In the sense, very important sensitive data like financial data or even the secrets of government, basically very confidential things of the government and all are stored in a, like no, in a, though it is a very secured one, but it is again, it is depending on only couple of systems, couple of servers. It is basically that way and all. So hackers, it is very easy for them to hack whatever it is required to do this one. But here, since it is distributed all together through the nodes completely, so and it is actually no, it is chained through the hash decimals completely, and any changes you make in one block, it will alter the hexadecimal, the signatures completely. You won't be able to get the entire records in one shot, right? Maximum you can get only that block data, not the entire data, because it gets immediately, once the hexadecimal thing changes, it gets disconnected from the entire chain. Unless otherwise you are able to decode entire hash on that one and put it over there. So that is where this distributed ledger works on that one. Now the important thing comes is the consensus. The consensus basically, like what is this sort of consensus? Consensus in the sense, basically, again, it is related to the transactions. Basically, as I was telling you earlier, if it is related to the the transactions, it is very easy, mainly because you would have given a key to actually approve the transaction and all, similar to your API, your client server networks and all those things. But basically, when we say without a consensus, basically, what we see in the left hand side, the diagram is basically all the nodes. Basically, if it requires, say, 6 people to approve, all the 6 should approve. Then only it will get added to the transaction is complete, something like that. So Understanding blockchain development means knowing the blockchain consensus mechanisms from which these platforms are able to perform. So now we see this as a, like, no, different types of consensus are there. Like a proof of work. Proof of work is more related to the Bitcoin blockchain, where I was telling you, like even now, even with this computer, what you are using right now to see this workshop, you can actually register for some sort of, like, no, like a blockchain network, and try to solve the like, no, generate some sort of signatures, basically the hashes and all. So luckily, if you get some sort of hashes and all, you are lucky, so that no, you can get a Bitcoin. Where what we call as a proof of work is mainly related to it's for miners. The miners, they get some sort of reward. That's called proof of work. How it is being verified is basically everybody knows that a block has been added. A Bitcoin block has been added to the network and all. You can go to blockchain.info or blockchain.com or something like that. They keep on publishing. They keep on publishing what is the latest block. This one has got added, because every day there will be some sort of like, no, blocks will get added to the network of blockchain, that is Bitcoin network. So it gets added. So every day they publish, which is the network, and also they also publish, like when you go to the blockchain.info and all, they'll also publish the latest hashtag also. Why this hash is getting published is mainly because you can start targeting that hash, saying that no, so whatever hash you are able to generate, you should match basically on that one. So that way and all, you can actually add so that you can mine one more Bitcoin. That is how. So the more the people mine, the more Bitcoins are available in the market. That is where it is there. Again, the proof of stake. So not necessarily like, no, all people should have some sort of like a similar proof of work where mines and all, where sometimes, no, some networks, blockchain networks, they say that no, like proof of stake, what they use some other mechanisms, like what do they do is that consensus, basically, no, like not necessarily all the things should be there. Maybe no, like 51% of people actually know, like accept it. They actually accept the block. Not necessarily that all people. Coming to the transaction level and all, you can, when you create a blockchain, for example, no, insurance company, for example, there are 5-6 people are involved. Say garage is involved, and so 2 levels of insurance approvals are involved on that one, and say probably, you know, like a hospital is involved on that one. So you can define saying that okay, if out of these 4 or 5 people, only 3 people accept it, actually you consider it as the completion of the block completely. So you can define those things and all. And delegated proof of stake, where no members of blockchain choose the other ones they want to approve transactions on, like that and all. Then proof of authority, where similar to, this is similar to POS, that is proof of stake, but here instead of that no consensus mechanism, they give more weightages basically. I'm just putting in a layman language here. For example, we like no, all the people who are all in the network, we are all like a blocks completely. I'm throwing a question to you. So like no, if each one of us is like a block like that, so like if say 50% of these people accept it, we can say the question is passed, like similar to our democracy, something like that. So a transaction is created as a block right now, and among the members, so if say like no weightage members, if somebody is maybe the moderator approves it, it is considered as it's approved by the entire thing, something like that. So you can actually assign the proof of authority so that the consensus getting that block getting added to the network, that way and all. So I was talking about the keys, like no, the keys where we use on this one. So you must be knowing about the cryptography, where no, like I don't know how many of you may be using the cryptography even for even mails. There are certain email like emails available, even cryptic emails are available on that one. Email services are getting are being offered like no on that one. So cryptography is classified into symmetric cryptography, asymmetric, and hashing and all. Where we find here is no private key and public key, which in normal blockchain transactions, when we used to do in that solid waste management, basically we plan to give these keys to the people so that no they get tokens, so they enter the token, so that no the project is all about I'll tell you about the project, then you'll be able to relate to that one, though it was on a voluntary mode. We did it. Basically, it is related to, for example, in Bangalore, there are say 200 watts the corporation has 200 watts. So the problem where we find this is basically, like every ward has got every day they actually pick up the solid waste, like the people who they pick up the solid waste and all. There is a lot of lag with respect to the waste picked and where it is deposited, how it is getting converted over here. So which was creating a lot of problems. Basically, like the lorries are carrying, basically there is a cluster. Basically, like each ward has got some sort of there is no specific place. Basically, like there are only 2 or 3 places outside the city where they can actually go and deposit the solid waste generated from the households actually. So on this one, so what we decided to do is that basically, like collect the solid waste, and typically people can acknowledge. For example, the plan was like even the household people will be part of the blockchain, so that once the people are have submitted their daily their deposited their daily solid waste to the outside guy and all, so they can actually press saying that no, the key is generated. They will be given a key and a hash is generated that will be added to the block. So next, actually, from there, it is actually, it goes to the small, the auto type of guy who picks up the small thing, where this guy will acknowledge that and get added. So then automatically, like it goes to the lorry level. From the lorry, it goes to that one. So, and there are vendors who are involved. There are payments involved. So the payments should be made to the lorry drivers. The regular payments should be made to the vendors, basically on that one. So all these things are considered as a blocks completely. So the point is that why, though it was actually it can be done even through the simple client server technology, basically, but there was a hue and cry, basically, because people were wondering that not every day the process is followed systematically on this one completely. So that was the hue and cry. So this we thought as a blockchain we achieved to some extent. After that it didn't move, mainly because due to technology issues, mainly because to adopt the blockchain in a public public area, basically like a public segment where you require a lot of infrastructure on that one, technology infrastructure and all. That is where, and also this I want to just give you an example of that one, mainly because to say that basically, like, don't confuse the blockchain with the bitcoins alone, where we have thought even to the solid waste managements to that level. So everything, any transactions where you feel that you feel that nobody should alter the data. At any time, you should be able to see who are all actually participating, and you can actually decide so many people should approve on this one. For example, if it is a blockchain, if you fix up, say that in the solid waste management, say 5 people should approve in this one, say ward committee is there, they should approve on that one. They have to put it over there. Whereas in another scenario, basically, you won't be able to, the client server technology related area, you need not put all those things. You can get a hold of this password and all those things, you can actually take it up. Even in blockchain, this is possible, provided somebody gives this private key. I was telling you this private key. The private key is like a secret key. So you can encrypt and decrypt completely. So in a transaction, for example, a block is newly added. I want to know what is there in the block and all. I can use my private key to get the public key. The key will be nothing but like the hexadecimal, basically. So that when I key in the private key, I will know the details of my public key related to the block. Once I enter that public key, I will be allowed to enter the block. Okay. Now, if I give my private key, it is as good as giving my password. So coming to the Bitcoin thing, if I am actually having say 50 Bitcoins, I am having a private key and I give my private key to the guy, he can actually take all the 50 Bitcoins on that one, because he will get all the required things to transfer the Bitcoin, sell it, whatever it is required on that one. So that is where we stand here. So some of the key terms, what is being used is like node, I told you. Again, I want to just reiterate so that people can remember the key terms on that one. So node is nothing but a user or computer within the blockchain architecture. On this one, a transaction is nothing but a smallest building block of a blockchain system that serves the purpose as for blockchain. A block is nothing but a data structure, which I told you already on this one. A chain is sequence of blocks in a specific order. And I should say that when we say a sequence of specific order, you can actually think about that, no, like all this linked list, all those things and all, pointers and linked list and all, which will define this specific order on this one. And the miners are the people who try to block verification process, who will perform the activity to decode this hashtag to add some structures to the blockchain and all. The consensus protocol is nothing but a set of rules and arrangements to carry out blockchain operations. Now coming to the very important thing is the public blockchain, private blockchain, and consortium blockchain architecture and all. The public blockchain is nothing but the data and access to the system is available anyone who's willing to participate. Like Bitcoin, Ethereum, Litecoin, blockchain systems are public. So that's what I was telling you. You go to the blockchain.com or blockchain.info, it's a public blockchain. So you can actually see the latest block added to the blockchain and the hash value of the blockchain. You can actually have a look at it. And if you having the blockchain, the hash generating software, you can try, so that if you have a luck, if it is matches, you can add one more block to that one. And if it is related to Bitcoin, you'll get a Bitcoin as a reward. If it is related to Ethereum, they call it as Ether completely, so that you will get a Ether as a reward to the, which is we call it as a proof of work on that one. Now coming to the private blockchain. In fact, the one what we tried, basically it's a public blockchain one. It's not completely public, it is public-private, something where solid waste management related to the thing. And private blockchain, it is controlled by users from a specific organization or authorized users who have an invitation for participation. So for example, if you buy a Bitcoin, so you will be given a key and the private keys and all, where you can actually decode and you can actually transact over it completely. So if you are transacting money, you can transact money where it will allow you to sell, buy or something like that. Or if you are actually you are in transaction oriented thing, where you can actually process those transactions, say approving an insurance claim or all those things, you can do that one. So consortium, this blockchain structure can consist of few organizations. A consortium, basically I was talking about an insurance company, consortium blockchain we can have, where if it is related to health insurance company, maybe a hospital will be having its own blockchain and the insurance company will be having its own blockchain, where they can actually pool this blockchain so that they can interact with both the users and all. Again, what are the differences between public and private blockchains here? The consensus determinations, public blockchain is all miners. Consortium blockchain selects set of nodes, whereas private blockchain it is only one organization. Read permission, public, I told you, you go to the website, you will know that. So you can actually go there. Our consortium is public or restricted. Again, it all depends on other things. You can do this one. Immutability level, almost impossible to tamper. Mainly because if I have to hack one, I need to get a Bitcoin through blockchain, through hacking. I should actually take hold of all the computers and make the changes and all. Is next to impossible. That is where. As consortium, it can be tampered. Private is also tampered, mainly because there is a limited number of computers. Second thing is that you can actually can catch hold of the key through some other manner. You will be able to do this one that way and all. If it is having limited number of computers in private and all, the nodes are limited. The nodes are limited. Say only 3 or 4 nodes are there and all. Then also there is a possibility of this one. So the more the blocks, the more the wide the blockchain, it will be highly secured on this one. It is as good as our democracy. So if there is an agitation, the more the people, the more strong the agitation on this one, more support on this one and all. So that way and all, the more the blockchain components, the more it is secured on this one. So efficiency use of resources like low, whereas in this other things are very high. There is no centralization in this one, and whereas in consortium blockchain is partial. Why it is partial? Mainly because there will be a lot of companies involved, so there is a partial. Whereas in private blockchain, it is related to, yes, there is a centralization. Again, don't confuse this with your client server. This is not your server. Basically, the centralization, what we are talking about is that a few slides back I was talking to you about like a master nodes and all those things and all, where it is like keeping a copy of entire stuff in one sheet basically. So that way and all, some centralization it is, yes. And consensus process is permissionless, but here you require a permission on this one and all. So far we covered some of the aspects of this blockchain here. So wanted to talk more about this the key benefits, where all it's getting used on this one. We find is basically like cryptography. For example, the blockchain transactions are validated and trustworthy due to complex computations and cryptographic proof among involved parties. And immutability, basically, as we spoke earlier, it is basically highly immutable when the chain is big on this one. So it's very difficult and all. Then provenance, possible to track the origin, where it is like you might have bought the properties and all. When you buy the property in sub-register office, so the first thing they will ask is the mother document. Basically, so the mother document will have all the transactions from the time it got introduced into the system. But of course, it is in the form of some sort of document in stamp papers completely. But here it is completely on that one. And in stamp papers, basically, you can make a changes on this one. But here you can't make changes easily because the hash will keep on changing that way and all. Then decentralization, each member of the blockchain structure has access to the whole distributed database, as opposed to central database system. Consensus algorithm allows for control of network. And anonymity. This is one more thing where government is more worried about is anonymity, where there are ways they are working to actually to overcome this anonymity on this one, because now sometime back I was reading that anybody can buy blockchain, the bitcoins and all, by submitting the KYCs and all those things and all. So that way and all, it is anonymity is there, and transparency. The blockchain system cannot be corrupted. That way and all, the transparency is got on the board. How the uses of blockchain, the cost reductions completely. For example, now if you look into that one, I'll draw a similar analogy for cost reduction. So in early 2000s and all, basically, there were only the desktops were being used in most of the software companies. Laptops were carried only by the very senior people, and later on, people moved from desktop to all laptops completely. So, and now after that, they find that a lot of money is being spent on laptop. Now they got into a system called BYOD. It's called Bring Your Own Device on this one. So gone are the days. Basically, the computer era in India started the computer's room. The computer room, when we have to enter, basically, it will be only in the AC room, where we have to remove the socks and all those things, getting into that one. Later on, people put the desktops anywhere, any place on that one. So that much the hardware also got up, got more affordable, and also the features also got improved a lot in the hardware. Then desktops were inside. Only laptops were given only to the senior people, mainly because they felt that a lot of data, sensitive data, is inside the desktop. Juniors will not know the sensitivity of that one. They may actually leak the data on this one. So most of the things are inside the servers, and access to it is very much restricted on that one. So then laptops, everybody started using laptop. Then bring your own, because you can't bring your own device inside the office earlier, mainly because people will suspect that you have got your laptop or something like that. Even if you find a CD or a pen drive, those days, this guy has come to take some data from the company and all. They used to suspect. Now they are freely allowing bring your own device, so you can take your home computer inside. But Why they are saying? Mainly because a lot of security features have been installed in your device, such that it will be impossible for you to take the data from there and all. And a lot of tracking mechanisms are there, so that you can't take some data and send by mail to your site. So automatically all those alerts mechanisms have been set over there. So cost reduction. So despite this, why we are talking about this? Mainly because still the companies spend a lot of money in servers completely, right? So sometime back also, when we had a problem with China, no, a question was asked to Nandan Nilekani at the time, saying that why can't we actually create a Paytm, or why not we create a Twitter on this one, right? Twitter is not a great, technologically speaking, it is not a great thing completely. But the problem here is why we are not able to create, he told very clearly, in the sense that is not a problem here. The problem is basically to manage such a big servers. We are getting a seamless experience in WhatsApp, Facebook, everything, mainly because the amount invested over the server, the cost is very high, such that they are able to process that much of data. We are not finding any hiccups while actually accessing Facebook or accessing Instagrams and all, because that much money is invested over here. So similarly, the banks are charging huge money because they are putting large servers to actually to keep the data. So for which also they are charging to us completely. Now, like how the BYOD, bring your own device, have changed the investment of the companies in the laptops and desktops. Blockchain is now challenging, saying that why you have to invest in servers basically, when all the data can be split and the data can be stored in your laptops through blocks. Why you have to invest so much? So this is now challenging the existence of even big banks. Correct? Why we have to keep this one? So we can easily have this one. Second, history of data. You can check the history of any transaction at any moment of time. Is ever growing archive. So uh, so you can check anytime. So it is like your bank passbook typically, right? So that way and all, you can actually go ahead and check it out on that. And data validity and security, where it is very impossible, next to impossible for you to actually validate the data, like security, insecurity and all. It is very difficult because of the processing power required by someone to hack this one completely on this one. So coming to the point where I thought something like, no, in fact, I asked the question also to this session people, basically when the organizers asked me, saying that given this, where do you think we can use this in India completely? Some of the things what I thought is like, registration of properties. Basically, we can use blockchains, where you can know about entire history of this one, and anybody buying. So like, if a guy is holding a land, and if somebody is trying to poach the land, change the properties in his name and all, it will be difficult for him to crack this hash code completely to add his thing to make the changes and all. That way it is secure. Similarly, vehicles and all, insurance claims, basically, like I told you an example also, bank loans basically. So we know that the loan, where it was given, how many people were given. There were a lot of frauds in the past, like the Nirav Modi and all, where like even yesterday I saw some frauds getting reported, where one guy will buy a loan from one bank and deposit in another bank, and get a good customer from the tag from the other bank, from use multiple what we call it as a fraud rings completely. So use that one to get loans and all, whereas these sort of things completely will avoid, because we know about this guy using this blocks and all those things. We know where all he has got loans and all those things across the banks completely on this one. And tax collections, we can use it, and especially while others are involved related to the money part and transaction, the best thing is the legal contracts. Basically, legal contracts can be used, so that we know where exactly the legal contracts, and typically we can even put if conditions and all on this one. Just a minute. You must have heard about in banking system, the accounts. Basically, like you can put all this the conditions before actually fulfilling the contracts. Then only the account should be credited and all. Like that, we can actually put this the contracts in this legal contract, so that they have to fulfill this condition for the legal contract to be closed. Like that, all those things we can actually do this one. As I told you, like earlier, there is like platforms like Ethereum and all those things are available. You can actually explore in the next few days. I think there's a 5-day workshop where you can explore this one, and actually you can actually take it up. Okay, now coming back to the drawbacks, where I find that you should be knowing about drawbacks is also like it's too much of computing. First thing, so for example, like if you are involved in say BPO type of operation, there is no use of blockchain that way and all. So this, in a thumb rule we can keep is that we can keep blockchains only in the places where sensitive data is involved, sensitive transactions are happening between places, where the question of trust gains more importance on this one. Of course, money is one of the important thing. Other than money, where the transactions where it's very sensitive, very confidential, and many parties are involved, which may require huge computing servers and all those things. Blockchain may break it up. So that way and all, you may not require huge servers and all those things like that and all. So that way we can do that one. And one more important, since I come from data analytics industry, I want to put this point also. So on one side, though we are having workshop on blockchain, the other thing which we talk in very much is about machine learning, artificial intelligence, and all those things and all. Whereas in a conventional thing like a client server architecture and all, it's very simple. You can extract data, do some machine learning, predict, and all those things. But it's not so simple from blockchain. Maybe you should have a master node, take the master node, take it up. It's not going to be a simple process on this one and all. That is one of the drawback. Though it is not impossible, it's possible. It's still growing on that one. So analytics becomes a little difficult when it comes to the blockchain on that one. So that is what we stand on here. So any questions? Hope you people enjoyed the session. And any questions you have, please let me know. Any questions? Hope you enjoyed the session. You understood it. In case if you don't understand, I know I can actually go back also on any specific thing.
Dear participants, if you have any queries, please it's time to raise your queries. So please unmute yourself and go ahead.
Hello, yes, madam.
Yes. So if you have any questions, you can unmute yourself and you can raise the questions to the resource person. We assume that there are no further queries to be raised with the resource person, and instead we would feel happy, as well as the resource person would feel happy if, as usual in the morning, any two participants at least will share your feedback. We would be privileged to hear from you. Dear participants, please. Yeah, and keep getting the messages in the chat box. I would feel happy if you guys unmute yourself and yes.
Good evening, sir. Shall I?
Yes, ma'am. Please.
Good evening, sir. My name is Gagana from Central University of Tamil Nadu, and I'm basically from Bangalore. And what sir was explaining, I can truly trust it, because the BBMP, the waste segregation, is the biggest problem, and practical application with blockchain accounting connection to the upcoming youths will be very informative, so that the problems can be sorted out using blockchain. So thank you so much, sir. And it was very interesting to know so many concepts which you have explained in a simplest way. And we will try to learn more so that we can use it for the academic purpose as well. Thank you so much, sir.
Definitely, madam. Thank you very much.
Thank you, ma'am. It's so nice of you to hear from you. Any more, please?
Actually, I kept a last 5 minutes, 10 minutes to just hear feedback and any questions and all. Because if you understand that basic, that like no, it's a light line of difference only. If you are able, because I find that many people get confused blockchain with the Bitcoin and like no, and always this mining or solving mathematical equations and all. That's what people report. That's not actually the case. So that's why I wanted to cover more of the aspects on that one, so that people understand the concept difference on that one. Yeah. Any other feedback? Anything you are not able to understand? Something like that, you can mail me also. I'll be happy to clarify those things.
Yeah. Okay. Yes, sir. So with that note, we shall now proceed to the formal closure of this day one. And to do that fitting job, I now request my fellow research scholar, Mr. Paul Williams, to deliver a vote of thanks on this occasion. Over to you, Paul.
Yes, sir. Thank you, sir. Good evening, all. Good evening, sir.
Good evening.
I, on behalf of the Department of International Business, Alagappa University, sir, express my heartfelt gratitude to Dr. Jayaprakash for having delivered a wonderful lecture on various concepts related to blockchain, sir. Also, sir, I personally found the concept of layman analogy was very interesting, sir. Thank you so much for explaining it in a very clear and lucid manner, sir. It was so interesting, sir. So thank you so much for your time, sir. And without such much preparation, it will not be easy for you to present it in a simple way, sir. And finally, I would like to thank the participants and also for their patient listening. Finally, at last, I would like to thank the university authorities and the our professor and head and other faculties of the department for organizing this program, sir. Thank you so much, sir. Thank you all. Over to you, sir.
Thank you, Paul. Yeah, thank you, Paul, for the hearty thanksgiving. Yeah, dear participants, we feel indeed elated in having you for the entire day. You are so superb. And at this point, I must tell you that we now will send you a mail to each and every one of you. That mail will carry the details regarding the assignment details for day one, and the stipulated time period for submission of assignment is by 10 a.m. tomorrow. We have received the questions from the resource person, and the same has been shared. And similarly, the photographs also has been uploaded in our Facebook page as well. We would love to share with you that as well. Whatever be the queries or suggestion for improvement if you have, please feel free to write to us. We expect all of you to join by 10 a.m. sharp tomorrow. Thank you. Thank you. Thank you, Anand.
Excuse
Thank
me.
you.
Excuse me, sir. Can you share the PPT or the recording?
Yes, ma'am. The recording will be made available in YouTube, ma'am. And whatever be the PPT or the other reference materials that our resource persons are using, that we will collect it by now. Will consolidate, and by the end of day 5, after having consolidated everything, the same will be shared to all the email IDs, ma'am. We have the registered email ID of all the participants, so certainly the same will be shared. Thank you.
Okay, video recording, when it will be available?
Video recording, ma'am, that we within 3 more days we will upload it, ma'am. 3 days from now. Yeah.
No, just
for the day one.
No,
for
no.
the day one.
No, the reason why I'm asking is if we have any clarification, we can get back to the presentation and look into it, no, before doing the assignment for that.
Yeah. I understand it. I understand. And I request yes.
I'll clarify ma'am's doubt actually. Actually, ma'am, this video link we cannot share right now. That we have to upload in AICTE website first, ma'am.
Okay,
From there you can see the video after 15 or 20 days. This
okay,
program.
okay.
PPT once we will receive from resource person, immediately we will share with all the participants.
Thank you so much. Thank you.
We informed resource person and will again one more time will remind them. Once we will receive, immediately we'll forward to you, ma'am.
Okay,
I'll forward the PPT to Mr. Raghu so that he can.
Thank you.
Yes, sir. Yes, sir. Yes, sir. Okay, thanks.
Thank you
Thank-
very much. Bye.
Thank you.
Thank you, everyone. We look forward to meeting you tomorrow. Thank you. Have a good day.